When we last left off on my DIY filament recycling saga, I was riding high, throwing confetti, celebrating my win, even uploading a compilation video to our second channel as if that was it. The project was done, a smashing success. But as the saying goes, pride comes before the fall. Plus, it seems like anytime I put up a video telling you guys how well something is working around here, it immediately falls apart. And unfortunately, my filament recycling setup is no different. And boy, did it fall apart. So in this video, I'm going to be experimenting with various ways to upgrade my DIY filament recycling setup, including testing some of your very best suggestions from the comments below. And who knows, maybe by the end of the video, we'll have a more robust, reliable, and high-quality filament recycling setup.
Wow, no way. Can't believe that it worked that well. So much for that.
That can hopefully inspire others, be it individuals or companies, to create their own solutions for this pesky 3D printing problem. Let's get after it. First, let's start with the shredder. When we last spoke, I noted that the shredder was still giving off metal shavings, which I believed was coming from the knives or possibly even the walls of the casing, and would go away with time. Unfortunately, not long after publishing, I discovered that it was, in fact, so much worse. Yeah, so despite the drive shaft being made of solid 20mm thick mild steel, I sheared clear through it. I spent literal months asking various engineers, friends, and even the creator of the original design what might have caused this, but nobody had one clear answer. And it wasn't until I went to go to rebuild it months later that I finally figured it out. And you guys are not gonna believe what a small, silly, and stupid mistake it ultimately was. In any case, while the shredder was quite literally in pieces, I took the opportunity to replace the custom 5mm sieve using a new mesh and laser cut frame from PCBWay. The old frame used some low-grade steel that I was able to source locally, and as a result, it had bent out of shape, making it very difficult to remove for cleaning. So I figured, why not make a new one while I figured out the rest of the issues? While that was happening, I also did some research on different types of steel and their properties. Because this project originally was all about seeing how affordably I could build a recycling setup, I went with a mild steel shredder kit rather than the more expensive stainless steel one. And to be honest, I regret that decision every single time I look at this thing. Not only does mild steel rust in my high humidity environment, but it's also not nearly as strong as other higher carbon alloys. But it turns out that there's a steel alloy specifically designed for exactly these types of applications, and wouldn't you know it, this video's sponsor, PCBWay, is able to machine it for me without issue. All I had to do was take my CAD file, upload it to PCB's website, and select Alloy Steel 4140. Now this alloy is not only known for its torsional strength, but also its resistance to abrasion and atmospheric corrosion, both of which have plagued the original drive shaft. From there, PCBWay had it manufactured for me and shipped out in no time, and as always, the finished parts arrived in perfect condition. This, my friends, is why I love and always recommend PCBWay. Working with them is just so fast and so convenient. It's so easy. Unfortunately, removing the corroded remnants of the broken drive shaft from the bearing was anything but easy. So I had to hand it off to a local subscriber, Shachar, who was kind enough to use a 20-ton press to remove it, but not without casualties. Nonetheless, I'm still super grateful to Shachar for his help, and I went about ordering new bearings to replace the old ones, which of course took about a month to get here. Rebuilding the shredder for the umpteenth time was honestly an absolute nightmare, not least because my kids managed to hide a very important spacer. I therefore spent half a day trying various ways to fashion one out of whatever steel scraps I had available.
My God, the things that I just went through to make a washer.
Only to find the original after everything was now back up and running. However, it was during this multi-day ordeal that I think I've finally discovered the mistakes that caused the shredder to fall apart in the first place. So, as you might recall, when I originally built the shredder, I had to rely on a Spanish instructional video. And I distinctly remember the video saying something about the importance of one of the spacers being on the inside and the other on the outside. Now, I assumed that inside means, like the inside of the shredder. But no. You see, this time, when building it, I referenced the CAD model instead of rewatching the video. And it turns out that inside means the inside of the hole that you're assembling the drive shaft into. It's kind of like one of those stage right, stage left things. In any case, I'd basically put the large spacer against the bearing and the small one on the inside, which either allowed material in or just ground against the drive shaft, or both. I don't know exactly what it was about this that caused damage, but judging from the fact that the drive shaft was cut clean through right where those spacers are, I think we can safely assume that this one tiny, stupid mistake is to blame. Somehow, throughout all my building and rebuilding the shredder, I never looked at the CAD close enough to catch this mistake. I just hope that the janky spacer I made out of the rim of one of the old ball bearings holds up, because I really can't stomach rebuilding this thing again. And for that reason, I feel like now is probably a good time to mention that the V2.1 design that I chose for its cost savings is actually already considered obsolete, and that if I were starting this project again from scratch today, or if you out there want to build this, you would definitely want to go with the reinforced version 3.3 or splurge and go with the Shredder Pro design, because all the parts that I've had to replace on this one actually have ended up costing me more money, and it's been more expensive and less robust than if I just spent the money up front. Oh, also, I'm pretty sure that I actually built the entire shredder backwards before, so lesson learned. When building stuff like this, the CAD model is actually easier to follow than an instructional video in your third language that you haven't practiced since high school. Who knew, right? But now let's go ahead and test out the rebuilt shredder and see how it works. So, great, things are working quite well, but we still have a number of issues and areas of improvement. In fact, a lot of the same issues that we've had since the beginning. Namely, there's lots of heat building up in the center of the shredder, and there's material accumulating in the sieve because it's smaller than what the spec for this shredder originally is. Now, these issues are, of course, interrelated. If material can't be expelled from the shredder, then it doesn't take the heat with it, and instead it hangs out, churning and causing more friction, which then heats the blades and the shredder even more, which then expand and create more friction. It's this really continuous, awful cycle until the thing eventually jams. In the past, I've tried a powerful turbine fan to push heat and create some positive pressure in the hopper, and it seems to work pretty well, but I still find that the best way to solve this little issue is just by tapping a hammer on the sieve to get it to shake and remove the excess material. But lucky for me, I'm not doing this alone. I have you guys, and you've all been really, really great about making suggestions for improvements in the comments, which I would love if you continue doing. Some of them are above my skill level, for sure, but others seem pretty realistic and feasible. So let's now go ahead and try some of them out.
And one of the suggestions that you guys made was, why don't I just put a vibrating motor? So I picked up a 12-volt vibrating motor. Let's install it and see if that will cause it to expel the material from the hopper faster, so that I don't have to tap it or have heat build up as the material goes over and over and over and starts churning. Let's try it and find out. Kind of occurs to me that we don't have a whole lot of place to mount this thing. This obviously needs to go in flush. I mean, I can try and mount it here on this side where the fixed blades are, and I don't think it's gonna affect too much the material going through. There's a lot of wasted space in this housing. I feel like I could just design my own housing, which would be much smaller, and it would also be a lot easier to mount somehow. I need to figure out, maybe I could get it to mount here to the screw that's already there. Let me hop in Onshape and see what I can come up with. Wow, look at that. Perfect fit first time. Hey, don't look at that. It's actually catching it. I can't believe that that worked. Oh yeah. Here we go, let's test. Let's put this guy in. Oh, what? No way. Bro. Yes. That's totally working. Let's get more material in there. The vibration motor just died already. After like a couple minutes, not even. So much for that.
Okay, so that was kind of a bust. It broke almost instantly, but I actually haven't given up on this idea, and I might try something a little more robust or just make my own vibration motor out of a stepper motor. So I'm putting a pin in this idea for now. Another clever idea that one of you shared was to add a heat sink to the outside of the shredder to help dissipate heat. Now, I've been procrastinating learning how to use the Carvera Air desktop CNC that Makero was kind enough to send over, and this felt like a pretty easy first project to really cut my teeth on. Yeah, I was totally mistaken. Modeling up the heatsink in Onshape took literal minutes, but machining it would end up taking literal days. First, I struggled with a bunch of weird soft limits.
Well, task failed successfully.
Then I realized that I'd used the wrong processes to calculate the toolpaths. Then, after watching tons of Makero's tutorial videos, I finally learned what type of toolpath I would need, only to realize that I needed more spacing between the fins. All the while, minutes turned into hours, especially because the all-new Makera Cam app was really struggling under the load of this geometry on my Mac. I lost probably an entire workday putzing around with this before I finally had the right toolpaths. And still, I was running into soft limits. It turns out that CAM and CNC are like way harder to understand and learn than 3D printing slicers, which is why I often recommend PCBWay. Still, I'm committed to learning how to use this thing, but for now...
You know what? For proof of concept, let's just do this manually. Yeah, that's good enough.
By the way, I'd love if you guys let me know in the comments below if you're interested in videos where I try to learn CAM and CNC. And if there's enough interest, maybe I'll do a video just about that. All right, well, let's go try this thing out.
Okay, so I just finished exactly 30 minutes of what I would call low intensity shredding. I had to stop a few times, turn it around. I wasn't feeding the machine very consistently. I was kind of coming back and forth, and I was hammering it out. Let's just check really quickly. Internal temperature is 60 C, so basically glass transition point of PLA. Let's install the heatsink and see if that improves things. Hey Siri, add more thermal grease to my shopping list. All right, that is 30 minutes. Anecdotally, I can say that it feels a lot cooler on the outside, and this time 30 minutes was actually 30 minutes of operation because it did not clog or jam up here once. I know it's not super scientific because maybe I put in less material this time, or I gave it more time in between because I was busy doing something else. But let's see after 30 minutes of operation what the temperature difference is. Wow, no way. Hold on, let's take out some plastic. 42 degrees Celsius. Are you kidding me? I ran it for longer this time and probably processed more material, and we brought it down by 19 or 20 degrees Celsius. Are you kidding? Okay, that's an awesome upgrade. I'm gonna have to find a better way to affix this, but that's crazy. I literally cannot believe that that worked as well as it did. No, seriously, I actually can't believe that it worked that well. I'm gonna run it another 30 minutes and see if the lower temperature maintains, because it's just too good to be true. All right, that's another 30 minutes of mostly running. I think it was empty for a little bit. I kind of, same thing, came and went. Let's have a look, see how warm we are inside. 42! Oh my God, are you kidding me? This freaking heatsink is keeping the temperature inside magically against all odds. It's keeping the temperature at 42. And I can, so far, run this thing continuously. Wow. Of all the things, I did not think that this was gonna make the biggest difference. Wow. Guys, have a look at this harvest. This is the most, by far, I've ever been able to shred without the shredder having problems. It still doesn't have problems, but I think this is more than enough of a proof of concept that the shredder is now working well. I can always shred more. It's not working perfectly. There are still definitely some improvements that I can and want to make, but for the sake of this video, I think it's working well enough for us to move on to some other components. So let's do that.
All right, another area of improvement for the new setup was going to have to be the filament pelletizer. Why do we need a filament pelletizer, you ask? None of your damn sorry. Because inevitably, when you recycle filament, you're going to get a lot of unusable filament at the beginning and end of a roll, or while you dial in your settings. And unfortunately, you can't just toss that bad filament into the shredder because it will come out as these long strands that will clog your extruder. So yeah, Pelletizer. Originally, I was using the open source self-feeding design by Michael from Teaching Tech with a bunch of minor community upgrades, but it still wasn't proving reliable enough, especially considering that my intended long-term goal was to connect it to a spare CNC spindle and just leave it running. So instead, I found this awesome remix, which has redesigned basically the entire thing in a lot of key ways. I'm not gonna bore you with all the details. I just wanna let you guys know that if you're looking to build a filament pelletizer, I would start with this remix design. I then printed all of it in some PLA Pro from this new company, Blend Maker, which based on my testing so far is incredibly strong, durable, and even heat resistant. So I'm gonna leave a link in the description below if you wanna check them out. And if you're wondering why print this out of PLA Pro instead of ABS or nylon or something like that, the reason is if it ever shaves off pieces, I don't wanna contaminate my pellets and therefore contaminate my regrind when I run this through. So we need a strong PLA for this. But now let's go ahead and see how the new pelletizer actually works. Hey, that's not bad. All right, fantastic. Let's get something on here so it doesn't spill everywhere.
Let's see how it works with low quality filament that doesn't have a consistent diameter. That's a little more problematic. Doesn't seem to like bent filament. Still not perfect. Try with a slightly better spool. Okay, all right, look at that. Spool's going. It doesn't like thin diameter or thick diameter. Yeah, there's no way I'm doing this manually. That's like 5 minutes worth of work right there, and that's it. I need to find a way to automate this and make it completely hands-off.
Finally, as you might recall, the shredder and pelletizer are only two parts of the comprehensive DIY recycling setup. We also, importantly, have the extruder, which in my case has been the ArtMe Mark II. Now, David over at ArtMe was kind enough to send over the Mark 3.5S, I think, upgrade kit for free for me to try out. Though I have to admit, I was pretty taken aback and a little annoyed by the fact that the upgrade process takes 8 to 17 hours and requires the complete disassembly of the entire extruder down to the bare extrusions. David promised me that the juice is most definitely worth the squeeze. According to him, this new version is not only safer, but also better for processing pellets, PETG, and other regrind, and other newer materials like high-speed PLAs. But that's just the beginning. It also offers a better mixing, larger extruder and heating element, which I sincerely hope is going to improve my material consistency and result in fewer bumps that end up clogging my 3D printers. It offers a geared stepper design for 24/7 operation, and it can even extrude 1 kilo every 4 hours. And if all that isn't enough of a reason to upgrade, the new version of the ArtMe now has an injection mode, which can be used to inject small DIY injection molds. Now, I'm not all that interested in injection molding per se, but my hope is that the lower purity requirements of injection molding as a process is going to allow me to use up the 20+ kilos of contaminated regrind that I've been saving up. So do get subscribed and comment down below if that's a video that you'd be interested in seeing. I basically don't make a video anymore unless you guys tell me you're interested in it. Anyways, I was lucky enough to have the help of a new intern, Nir, who spent the better part of 2 days disassembling my Mark 2.5. Thank you, Nir. And now it's time to get building. And you guys know what that means. Cue the montage.
Hey, we got our first spoop. Very consistent, actually, considering I didn't dry the filament. We need to go dry some filament.
Hell yeah. Throughout this video, which honestly has been many months in the making, we have made some very serious progress. I now have the shredder running much better and much cooler than ever before. And I have a half-decent pelletizing solution for reject filament. And then as far as the extruder goes, after some initial firmware configuration, it seems like it is going to be much more reliable at churning out higher quality filament. But I have also definitely learned my lesson about tempting the fates with some sweeping declaration of victory and how great everything is working. So instead, I do want to close this video on some future improvements that I intend to make and some of the issues that I still need to solve. After all, we're in this together, and it is many of your comments which have gotten us to this point. So first, the shredder. I do still need to hammer on the bottom to get the material to come out properly, and I really do want to try to get a better and more robust vibration motor going for actually automating that. Additionally, it is pretty annoying to have to go back and forth into that room to feed the shredder every minute or so. So I plan on adding some kind of secondary hopper that uses the vibration of the large motor to slowly and gradually feed in small pieces. Finally, there's the heatsink. While the initial proof of concept was honestly way more effective than I could have possibly imagined, I do want to try and make a proper heatsink. But I need to find a way to get it to sit on there, more importantly, especially since the shredder housing has actually bowed out and it's not making enough contact. To my knowledge, there's no way to weld aluminum to steel, so if you have any ideas that are better than just globbing on a thick layer of thermal grease, do let me know in the comments. As for the pelletizer, I think I can still make some tweaks and optimizations to get it to run more reliably, especially with filament that's thinner or thicker than the ideal diameter, which is the kind of filament that I would be pelletizing. But as I was making this video, David from ArtMe also let me know that he's been working on his own much more reliable pelletizer design. So I'll be trying that out in a future video when he gets it finalized. I definitely need a solution that is self-feeding, or I'm gonna lose half my day just doing that. But I'm also concerned that a lot of the filament rejects that I need to pelletize are not full spools. They're 5 meters here or there. And I really don't want to end up having a full-time job feeding the pelletizer and the shredder. So I might try just putting the refuse filament into a blender or something like that.
This thing is handling it like a champ.
If this video does well, I'll do another video with more optimizations, including your comments down below. And finally, there's the extruder. While it is definitely working better than ever and seems to be much more reliable, I still do have some tweaking and tuning to do, and I've yet to actually calibrate the new filament diameter needle, which is a new feature on the Mark III. So I'll have to go ahead and get that done after recording. See, Murphy's Law, I'm not done, the project is not perfect, and I'm not a genius. Please, just leave me alone. Anyways, all of this constitutes a major milestone for this project, and I really appreciate all the help and support that all of you have given. It's my sincere hope that all of my experiments and costly mistakes will help someone out there develop a better, cheaper solution for all of you. At this point, I think I'm in about $3,000 of my own money on this, which is a great segue into telling you about these new limited edition t-shirts that we have on sale now at shop.thenextlayer.com. We're only going to be producing 500 of these, or until I get a profanity strike on YouTube for wearing them, whichever one comes first. Anyways, that's all for this week, but I'll see all of you on the next layer.